Morning, students. Welcome to lesson 10.4 lesson video. And in this video, we are going to continue with this idea of probability, but we are going to explore a little deeper into calculating different types of event sample spaces. Okay, so really there's only one main key idea in this section, and it's how we determine the possible outcomes when we have more than one event. Like I always go back to flipping a coin because that's a very simple but easy way of kind of understanding this. It's not always the case where we flip the coin just once. It could be that we flip the coin twice, 3 times, 4 times, 5 times. There's so many different combinations that can possibly happen, and that's really what we're talking about here. The set of all possible outcomes of one or more events is called the sample space. Okay. We are going to calculate sample space by using a couple different techniques. There's tree diagrams, there's tabling, or there's also this fancy thing called the fundamental counting principle, which when you see it, all right, it doesn't sound, or it isn't as hard as it sounds. Okay. So first thing I'd like us to try, and this is probably one of the main ways that you're going to figure out sample space. Sample space means I want to know how many different combinations there are in a way. Combinations is, I'm going to quote that because technically sample space, okay, whatever, don't need to call it combinations, but it's similar in that thought. So we have this situation. We have 2 different types of crust for a pizza and 4 different styles, okay? How many different pizzas are possible? So we're trying to find this sample space. So to do that in a tree diagram, I'm going to create a tree diagram that branches to each, that makes a connection between each thing in the first event and each thing in the second event. So crust is event 1, style is event 2. So I'm going to put event 1 in the first column. You have 2 choices, thin or stuffed. Notice I'm going to space it apart a little bit because once you see this tree diagram, you're going to notice why that I had to use a little extra space. If I choose thin, I have 4 more choices. It's either going to be Hawaiian, Mexican, pepperoni, or veggie. And I'm just going to use a quick little notation here because I'm not going to write out all those words. But notice, if I choose thin, then I got 4 more choices afterwards. Hawaiian, Mexican, pepperoni, and veggie. So that's why I'm going to create a tree branch to all 4. Now say I choose stuffed. It's still going to give me 4 choices because in this case, okay, it doesn't change what event 2 combination is. So in each of these, it looks very similar. It's going to be kind of like a reflection of the above one. But what you should notice from this tree is that now in the last column, that's this column right here, okay, in the last column, it tells us what our sample space. We're just going to count. Okay? So in this, I got 1, 2, 3, 4, 5, 6, 7, 8. There are 8 possible, okay, 8 possible for our sample space. So when we're thinking about using a tree diagram, as long as the tree diagram branches out accurately, we look at the final column to count how many possible combinations there are, and that is going to become our sample space. So the tree diagram is very smooth. It definitely takes a little bit of practice to get a little bit of the spacing and how far you got to go with this, but with practice you should do pretty well with it, okay? And then just remembering that you got to count the last column, okay? And I'll put that in our notes right here. 8 possible, count the last column, and that will be our sample space. All right, let's try something a little bit different. All right, I'm going to go move down to the table example. It says, find the total number of possible outcomes of rolling a number cube and flipping a coin. So in a number cube, there are 6 possible, and flipping a coin, there are 2. So I could use a tree diagram, okay? But instead of that, I'm going to go ahead and try a table. So say I have heads and tails as my first event, and then I have 1, 2, 3, 4, 5, and 6 for my number cube. So as you can see here, I'm using the grid on my screen. These are the possible combinations, H1, H2, H3, and so on and so forth. And you can see it gets a little repetitive, but the nice thing about a table is that it's going to give us a super organized way of going ahead and tabulating all of this information. So once we have that, the total possible outcomes are going to be inside. So the sample space, okay, so the sample space, and I'm going to call it just sample space this time instead of total possible, it looks like there are 12. There are 12. Okay, 12 different ways that we can roll a number cube and flip a coin, or 12 different combinations. So let me zoom out here. Both methods are perfectly valid. Personally, I like the tree diagram. I feel it's quicker, faster, easier to kind of read, a little more challenging to create versus a table. Okay, but be comfortable with doing both. Okay, at this point, pause this video if needed before I roll on to the next set of examples. Okay, so I moved the key ideas down here because the fundamental counting principle sounds way fancier than it really is. Okay, basically it says that if we have multiple events, so let's call well, let's use the letters that are up here, okay? If we have multiple events, and the first one is n possible events, okay, and the second one is n, we can find the actual sample space, or the total number of outcomes, by merely multiplying it. And it's kind of like, if we look back here at these previous examples, it works as long as we have this situation where we have very specific events and how many times they can occur. If there are 2 crusts and 4 styles, it's 2 times 4, 8 possible. If there are 6 sides to a cube and heads and tails, that's 2. 6 times 2 is 12. So the fundamental counting principle allows us to multiply how many times something occurs in each event, and there we get our sample space. It's quick, it's easy. We just got to remember or be careful in how many are in each event. And it works if there's more than 2 events. So let's look at this. This is a classic example where you're looking at a closet with different combinations of clothes. How many different outfits can you make from t-shirts, jeans, and shoes? So for the t-shirts, okay, I'm looking here, it's a little blurry, but I'm seeing 7. Okay, there's 7 t-shirts. For the jeans, it looks like there are 3 up at the top. There's that little hidden purple one right there. And then for the number of shoes, it looks like there are 3 pairs of shoes. So according to the fundamental counting principle, okay, I'm just going to call it counting principle, CP. Actually, let's I've used that. Let's just call it FCP. Okay, just to avoid confusion. Usually, I have old school math. You usually use CP, but we'll call it FCP for this case. FCP, fundamental counting principle, tells us that we can use 7 times 3 times 3 to calculate the sample space. So using your handy dandy calculator, and I should know that off the top of my head, but it is 63 different outfits. Now, look how smooth it was using the fundamental counting principle, because imagine if you had to use a tree diagram or you had to use a table. It'd be a little difficult with the table with 3 events, but a tree diagram would have worked for this, and you would have had to count 63 different combinations at the end. That is way too much work. That's why the FCP is very smooth. Okay? Let's try one more here. How many different outfits can you make from 5 t-shirts, 3 pairs of jeans, and 2 pairs of shoes? Well, FCP equals 5 times 3 times 2, and in this case that comes out to be 30 different outfits. So the fundamental counting principle is something that I definitely expect you to utilize. Let me zoom out so you can see the whole thing, versus the tree diagram and the table method. All of them are valid, but the FCP allows us to do things much quicker, easier, faster. All right, with that being said, pause the video if needed, but let's scroll down to the OYO section. All right, in the OYO, I got a couple situations here. Okay, so take a moment to go ahead and pause this video here. I'll let the video roll, and the answer key will pop up in probably about 5-10 seconds. Okay, try these on your own. All right, since the answer key should pop up, so number 1, straightforward, tree diagram. You can see mine. I did use just abbreviations, use the first letter just because I don't want to write out the whole word. It's perfectly fine. 9 outcomes. Number 2, use FCP, 4 times 5 times 2. Just got to count how many versions of each event. There were 4 shirts, 5 colors, and 2 styles. This one right here that's not numbered, okay, using the FCP in this case, spinning the spinner, there are 4 possibilities. And then I multiply by 5 because choosing a number from 1 to 5. The last one, the flipping the 3 dimes, this is a great situation where using a tree diagram is probably the best method. So if you notice, I created a tree diagram, spread out my data appropriately. Here is event 1, event 2, event 3, flipping the coin 3 times. To get the probability of 3 heads, I need the sample space, which is 8. I counted the last column. There are 8 possible combinations. And how many times does heads, heads, heads comes up? Well, it's right here. Heads, heads, heads. It only occurs once. So therefore, the probability of getting 3 heads is 1 out of the 8 possible. Okay. All right, students. So that concludes the video lesson for 10.4. Take a moment to go into your Big Ideas Math line. There should be plenty of work available for you to practice these methods. Okay. Please review it if needed, this video that is, and feel free to reach out if you have any questions. All right, thanks.